All right, let's take a look at the Desmos activity for today, linear and nonlinear functions. Slide 1. So in class today, we had a good discussion about observations that we see on this graph. People noticed right away, obviously, there's two different graphs happening. There's the red one and the blue one. And it says, what do you notice? Similarities or differences? Well, the differences is the easy one. And this is what we said about the differences. So we say the difference we see is the blue line is straight and the red line is curved. The similarities, we actually were able to find 3. Both of the graphs are increasing or positive because both of them go up. We noticed that both of them represented functions because each input on the each number on the x-axis, when you look at the y outputs, only has one y output. So when I go up and down, each one only hits the graph once, only looking at one graph at a time. And then lastly, what a lot of people noticed was these two graphs intersect one another in a couple places, but the one place they intersect that is significant to us is right here on the y-axis. So we said both graphs cross the y-axis at -2. Now, when we go over to slide 2, now it wants you to specifically use key vocabulary from this unit right here, linear versus nonlinear. The red line, of course, would be what? It's curved, so it would be a, you guessed it, nonlinear function because the line is not straight. It curves. That means the blue line should be linear because it shows a straight line. That is not how you spell line. Sorry. Easy enough, right? Slide 3 and 4, I'm not going to show a demonstration of because I want to see what you're able to do. However, this one, you're going to sketch your own example of a linear function. Keep in mind, what does linear mean? Well, on a graph, it means a straight line. So you are going to want to use your line tool. Give me a straight line, increasing, decreasing, positive, negative, horizontal, vertical. As long as it's a straight line, you'll get credit. Slide 4, now you want a linear sketch. Doesn't matter what it looks like as long as it's not a straight line. But please don't make a big scribble all over the slide like a 4-year-old would do. Give me something that looks somewhat like a graph in math class that's not straight. On slide 5, now we're looking closely at the two equations. The blue graph was formed with this equation, y equals x minus 2. You'll notice right here, we have a straight line, meaning because it's linear, we have a slope of 1. We have a y-intercept of -2. Because it's linear, we could write it in the form y equals mx plus b. The red line is given with this graph. The red graph is formed by this equation, and what do you notice is different between this equation and the blue one? They're almost identical with the exception of this piece right here, this x to the second power, or x squared. This exponent of 2 is what makes this line bend up like that. So the equations, both equations have a -2. However, the red equation has an exponent of 2 on the x. Now, what do you notice about their graphs? The blue graph, obviously, is a straight line. And the red graph, exponent of 2, shows a curved line. My fingers do not want to spell line correctly. All right, pretty basic, not super high tech. This is just 8th grade. You're going to get a lot more into this next year in high school. Slide 6, real quick card sort. Linear, nonlinear. keep in mind these two graphs right here. The red one, curved line, nonlinear, and what did it have that was significant on it? It had the exponent of 2. So we know right away this exponent of 2 is going to be nonlinear. Now, this one has an exponent of 3. Same idea. None of our linear equations we've worked with in this unit had anything to do with exponents. So that one's going to go there. This one, boom, all correct. We feel good. Pat ourselves on the back. You don't really have to do much on this slide. This was just to keep people busy while they were my people that work faster. This slide, you're going to make some observations. Over here on the left, you see 5 equations. All of these equations have something in common. I'm not going to ask you to graph them yourself because magic of computers. This circle next to the first equation, y equals x, if you click the circle, it actually draws the graph for you. Red line, increasing, straight, it is linear. I can click it and turn it back off. Look at the second one. Same idea, right? Linear, straight line. The third equation, same idea. Fourth equation, yep. Fifth equation, yep. All of these equations turn out to be linear equations because even though they have fractions, decimals, whole numbers, some of them don't have any numbers showing at all. They're all linear. So on slide 9, that's what we need to talk about. All the equations have x's with no exponents showing because there's actually an exponent of 1. We just don't have to write it. No exponents showing and can be written as y equals mx plus b. Clues you would look for when deciding if a function is linear. Well, no exponents on the x, and typically a slope or a y-intercept. Basically, equations that deal with what we worked on this year so far. On this first one, the slope would be 1 because it's 1x. The y-intercept would be 0 because there is none. Second one, slope is 2, y-intercept is 0. Third one, slope is 3, y-intercept is 4. Fourth one, slope is 1/4, y-intercept is -2. You get my drift? Yep. Slide 10. What do you notice about all of these? These don't look anything like equations we've worked on in class yet. We'll do some things with this stuff later in the year, but so far, this is what we got. I want you to see how each graph changes based on what it looks like. This x to the power of 2 gives us that curved line that we saw earlier in this activity. Turn that one off. This equation right here, the second one, has those bars. Those are called absolute value. That's the symbol for absolute value, means distance from 0. If you've listened to me at all this year, distance can't be negative. So when you turn this one on, you'll notice it looks like a V and both lines are only pointing up because no matter what x value we get, we're only going to have a positive y. Both of those, by the way, not linear. Third one, now we've got an exponent, but it's to the power of 3. When I turn that one on, instead of it being a u, half of it's a u, the other half flips down. Not linear. Look at this one. This one looks a little different because it has a fraction, but on the fraction, the x where it's normally on the side or at the top, our x is on the bottom. When you divide by an x, this is what happens to your graph. Never seen anything in class like this. I'm not going to in 8th grade, but this is what a variable at the denominator of a fraction looks like. Not linear. And lastly, this is called a square root symbol. I know the keyboard icon that I call it the fancy math button, not a division symbol. We'll learn more about this when we get into units 3, or not unit 3, second semester, 3rd quarter. But this is what happens when you get a square root symbol around the x. You get a graph that looks incomplete. So looking at all of those, what do all those have in common? Well, none of them are linear. So let's go to slide 11. When a function is nonlinear, I might see or notice, I'm going to talk about these two things first. Exponents, yep, that are greater than 1. So 2, 3, 4, 5, any of those would apply. This next one, Remember what that's called? That's called absolute value. So exponents on the x that are greater than 1, absolute value of x. This one, x as denominator. Yep. And lastly, the square root of x. Any of these things in an equation are going to make it nonlinear. Now, slide 11 and slide 9 are going to be the most helpful for you with getting slide 12 done. Slide 12, you're going to have two sections. You got linear and you got nonlinear. The graphs are probably the easiest because the linear graphs, obviously, all are going to show a straight line. Nonlinear, not a straight line. The equations might get a little bit tricky, but that's where you go back to slide 9, read what we wrote, and slide 11. Anything with an exponent, an absolute value symbol, x on the bottom, any of those are going to be non-linear, okay? If it can be written y equals mx plus b like this one, it'll be linear. Hope this helps. Tomorrow we have our review for our unit assessment on Wednesday. I will have a video over the study guide for tomorrow. It's already ready for you. And let me know if you have any more questions. See you later.